In this section, we're going to take a look at one more example of being able to use a while loop. And the previous, we did a pretty basic example of just rolling 2 dice and seeing if you would win versus the computer would win, that sort of simulation. In this example, we're going to take a little bit harder mathematical look at using an infinite series as well as a while loop. And one of the things that you might remember if you took calculus 2 is that infinite series can be used to represent transcendental functions. So for example, this infinite series can represent the cosine function. So one of the things we might want to do is we might want to figure out what order of a polynomial is necessary to get to a specific error. And this is exactly what a calculator might do, like your TI 83 or 84, or if you use something like Wolfram Alpha, it gets up to a specific error and then it stops using this approximation. All right, so this is how your computer actually computes cosine of 3, cosine of 5, those sorts of things. We're going to use a while loop, and we're going to use this representation of cosine, and we're going to figure out what the cosine of a specific number is. So cos of 3, cos of 2.1, etc. We're going to use a while loop to approximate that cosine until the error is less than 1%. And we're going to print out a table. We're going to print out the order of the polynomial, the actual value of the cosine, the approximation by the infinite series, and then the error that's involved with that. First things first, let's get the value from the user. So let's say n is going to be equal to input, and we're going to say enter the value of cosine n to approximate. All right, and of course, we're going to have the actual value. So actual is going to be equal to cos of n. Next thing we're going to do is we're going to define an error. Now, what I'm going to do is I'm going to define error to be equal to a very large number. And what this does is that it ensures that the algorithm will run, or the loop will run once. Okay. Next thing we're going to do is we are going to start a counter. So I equals 1, or 0, excuse me. And this is going to be the iteration of the infinite series. All right. So for instance, and remember that we're going to have I equals 0, 1, 2, 3, etc. If we go back to our formula has, instead of we're going to have k in our formula. So if we really wanted to, we could just use k just for consistency's sake in the formula. And if we really wanted to, we could just have x up here. So that way everything's the same as what we have on the sheet. Okay. All right. Last thing we're going to do is, before we actually get into the loop, we're going to define a polynomial. And this is going to be the approximation. So the polynomial is going to be equal to 0 for right now. Okay. And this is going to be our approximation of cos of x using our series. And then the last thing we should probably do is we should print out the header. So I'm going to have an f print f. And remember, we have our order of the polynomial. And then we are going to have the actual value. And then we're going to have the approximate. And finally, we're going to have the error. All right, and that's going to be \n. All right. Now, what we want to do is we want to keep doing this. We want to just keep adding on to the polynomial. All right. So if we go back to over here, just to kind of show you what we're doing with this. So when k is equal to 0, that means we get -1 to the 0, x to the 2 times 0 divided by 2 times 0 factorial. When k is equal to 1, then we get the exact same thing that we did in the previous, except we're going to add on -1 to the first, x to the 2 times 1 divided by 2 times 1 factorial. And then we're just going to keep doing that. So in other words, each time with our loop, we're just adding on one more term to our polynomial. And that's just going to keep getting us closer and closer to the actual value. Right? So hopefully that makes sense as to what we're actually doing with this loop. All right, now let's go ahead and actually do that. Get rid of this stuff. So we're going to make our while loop. And the condition is that the error has to be greater than 1%. So while error is greater than 0.01, right? So we're just going to keep doing something. So our polynomial is going to be equal to the current polynomial plus the next term, right? And remember, we defined k to be equal to 0, right? So that means that we're going to use the formula. And remember, our formula is going to be -1 to the k times, and then we're going to have x to the 2k. This would be x raised to the 2 times k. And then we're going to divide that by factorial of 2 times k. So each time, just what we're going to do is we're just going to add on the next term in our series. Right? So the poly is the previous term, and then this is going to be the next term in our series. Right? At this point, we're going to compute an error, and error is going to be equal to the absolute value of the approximate, which is poly, minus the actual, and we're going to divide that by actual. We're going to print out the polynomial, the error, the iteration. So we're going to print f, and we are going to have a %d for the order. So we have a %d, and then for the actual value, we have %f, and then for the approximation, we have %f, and then for the error, we're going to have %f. And I'm going to line these up when we're done, but just for now, I'm trying to compute it. And the \n means we go to the next line. I'm going to put this in wrong. So I'm going to have I for right now, and then we're going to have the actual, we're going to have the error, I'm sorry, we're going to have the polynomial, which is the approximation, and then we're going to have the error. Right, and then the next thing we're going to do is we're just going to increment one time. So I equals I plus 1. All right, so that means that what we've done is now we're going to the next term in the polynomial, right? And that should be it. So it's just going to keep doing this while until we're done with the error. All right, so let's go ahead and execute this and see what happens. All right, so at least it's running. So, and I spelled approximate wrong, but that's okay. Let's try 5. All right, and it looks like that we are in an infinite loop. All right, so if we get an infinite loop, we're going to do a Control-C, and we're going to break out of this. Okay. And so that's not good that that was to happen. So I'm going to go all the way back, and we're getting this weird number up here as to why it's not running. So let's see if there's something that I did wrong here. So I'm going to go back to our formula, and we have -1 to the k, x to the 2k, 2k factorial. And down here, we have x to the 2k, and x is going to be the input. And we defined our error, and we have k is equal to 0. It's because of this I right here. This needs to be k equals k plus 1. I think I was so stuck on using odds. There we go. Let's give that a try. And I'm going to print out k. All right, let's give that a try. So there we go. All right. So it looks like that this is the actual value. All right, that's good. And then the approximate value, and for those of you that have worked with this cosine, it starts out being really messy. All right, the closer you are to 0, the better it is. Now, there is one thing wrong with this, okay? And I'm going to run it again just to show you that this works. Here, I want to put in 9. If I try a number that's closer to 0, like 2, it doesn't take as long. The closer that you are to 0, the better it is, all right? So if I had something like 0.4, all right, it actually gets really, really close, all right? Now, if I had something like 50, it's weird that I must have just picked a really weird number. Let's try something like 15. All right, it's going to take a lot of iterations to be able to do that. Notice it's only printing not that last iteration. It's because what's happening is it's computing the error and then it's kicking out. So we really just need one more iteration than what's happening. So what I'm going to do is I'm just going to copy this. All right, and what this will do is this will actually print out what we really wanted to do. All right, so it looks like it terminated before we get to 1% error, and that's okay. That happens sometimes. All right, and there's one other thing that I have to do with this. For those of you that might remember, the cosine is an even function. So this actually needs to be 2 times k. All right, if you look back at the formula, and this is just a math thing, is that you have x to the 2k. So the order of the polynomial is always even. So it's 0, 2, 4, 6, 8, 10, etc. All right, just because of this. So I'm just going to double whatever k is each time, and I'm going to do that right here as well. So I'm going to run this one more time, and let's try something like 10. All right, and notice down here, it gives us that last iteration that we needed. All right, and notice how close we are. All right, even though it says 28 is the order, that only means that we ran it 14 or 15 times to be able to make this work. So that's how we would try to run this sort of thing with the while loop. We're going to be using this sort of structure a lot throughout the course, where we use numerical methods to be able to approximate a solution until we get to a specific error. Oh, by the way, that should be 0.01. Maybe that's why it didn't run. But that should do it. I see what happened. I just put in the wrong error. I put in 10% instead of 1%. So we shouldn't need this at this point. So I'm going to run it one last time. Let's just say 10. There it goes. Okay. So I apologize. I just made a typo right here. All right. So pretty cool that now we can approximate the cosine of a value. We use a while loop to a specific error. And if we wanted to make it even more precise, we could just go ahead and change the error. And of course, it's going to need more runs. But let's try something like 15. And notice after 15 iterations, it gets really, really close. So we're accurate to, it looks like that 10,000th place. I don't know what happened there. It looks like a copy error or something like that. Okay, so we're all done with loops. And the next videos we're going to start taking a look at is we're going to start taking a look at the idea of using a function in MATLAB.